Well, it's about 5 after. Let's go ahead and get started with this last chapter of the whole class, the last 2 weeks of class. So this chapter is on packaging and deploying your apps. We have 4 learning objectives for this chapter. We're going to identify the steps required to package a mobile app, manage package and directory nodes right there in the project view. You've probably noticed that we have some built-in package and directory nodes for packaging for our BAM mobile projects or mobile projects in general come with those. So we'll just learn to manage those, and we'll look at the properties and see which properties we need to be concerned with and which ones we can mostly leave at the defaults. And then we'll build and deploy a package for testing. And by that I mean just maybe even just deploying it to an emulator for testing so that we can see how it runs in standalone mode and make sure there's not any big issues to try to fix before we distribute that app to users, which is our last learning objective. So 4 different learning objectives for today. So packaging a mobile app. A package is just a bundled file that has all the files you need to run your app on a mobile device. Android packages, when you create them, have a special extension that ends with a .apk. iOS packages have a different extension, ends with an IPA. So those are our package results. When we learn how to build a package in this chapter, that's what we get when we're finished, is one of these special flat file packages that contain all of our files bundled up so that we can deploy them over to our mobile device. So over on the right-hand side, you've probably noticed this at some point the last 2 weeks. These are the built-in package nodes that we have when we build our new BAM mobile project. There's 4 of them, and you can see there's one here for Android devices. That's what the Android ARM package is for. Most of your Android devices fit under that category. We also have one that's primarily intended for the Android emulator, the x86 configuration that you see second there, the package to build the package node to build a package for the x86 versions of Android. So that's our emulator for the most part, but there's a few other special device exceptions to that rule. And then we also have 2 different package nodes for iOS. We have one for iOS devices and then a separate one here for simulator. So if you've been working with the simulator for Android or iOS, there's a special package node just for that. So this is talking about the packaging process. It's not a long ordeal to do packaging. There's just 3 or 4 steps that you need to go through, and they're fairly simple steps. So the first step is to make sure that you know all the files that you need to bundle up in your package to deploy to the physical device. So identify the files that are needed for the application. So that's not just binary files, it's not just your runnables. You also need things like your image files, like that the JPEG we use for our splash screen, for example. We have to make sure we include all of our image files. We've got web component files that we talked about yesterday that we need to make sure end up in our package. So in our case, our splash screen gets displayed properly when we deploy. So there's several different types of files that we need to make sure we have all gathered up and ready to deploy. So that's the first step, identifying all the files. And then once we've identified the files, we need to figure out what kind of a directory structure that we want on the device. So we have to organize them so that we can get them packaged, and then we have to determine what kind of a directory structure we want to have when we deploy the package. And then finally, once we've figured that out, we're ready to create a package, very simple step, and then we're able to deploy that package to a device. It might be a physical device or it could be an emulator. For our lab this afternoon, of course, we'll be just deploying to an emulator. So here's the step on identifying the required files. So not just the binaries, I've got an entire list over here on the left-hand side of the screen of all the different types of files that your application might use that you need to make sure you've accounted for. And we'll talk more about how you account for them in just a minute. But for the first part here, identifying them, your binaries, of course, are important. Your runnables, those .42Rs we've talked about a few times in class. But you also need your FGL profile configuration file because it's got information, for example, for your database connections, and it might have some special environment variables that you can use with mobile in there. So you need that configuration file bundled with your package. Your database, right? One of the ways we talked about deploying a database for a mobile app is to actually include it in the package. If you remember, there were two different ways we could account for that. One of the ways we can have a database on the physical device is to create it the first time we run the app on the device. But the other method was to actually package the database and include it when we deploy the app. So we've got the database files here listed. Images, I just mentioned that if you use images with your application, like the one we use for our splash screen, if you remember, we also have some images that are displayed in various list views in our app. So all of those need to be included in our package. Library files. Got some library files that are automatically accounted for with our BAM mobile projects and the defaults that come with that. But if you have any additional library files, you might have your own libraries, you need to make sure that those also are accounted for. Resource files, remember a couple of days ago we were talking about action defaults files, we had presentation styles files. All of those need to be included when you package your app as well. So any resource files, toolbars, top menu files, styles files, and so on. And then finally, I've already mentioned any files that are associated with your web components. So when we talked about web components yesterday, especially those GICAPI web components, remember have various files that have to be packaged with those web components. They're part of the web component, so they have to be packaged along with all of your executables. One of the things you can do to kind of help you remember where you might have stowed certain files, it's really nice when you have these BAM mobile projects like we've been working with this week, because remember it has the built-in default directory structure. And if we just made sure that we saved our files to these built-in directories, we had an images directory, we had a special web components directory underneath our project directory structure. And if we used those directories as we were building our project and working with our application, we don't need to worry too much about having to find them wherever they might be on the system, because they're already in the standard directory structure. But let's say that you have a project that you've been working on for a while. You're not sure that you've got everything in a standard location. Maybe you created your project from scratch. So one of the things you can do to try to help you remember your files and locate your files is check out your file properties that you have right there in the project view. Remember, you can select a file and open it up in Code Editor, and the properties will tell you, for one thing, the path for that file. So if you're not sure where things are, you can open them up right there in Genero Studio that comes with Genero Mobile, and you can look at the properties for the files and figure out where a lot of these files might be located. Another way, probably a faster way, is to use your environment variables. If you remember, we went in and right-clicked on our application node, and one of the options you get in your right-click menu is to display environment. So if you look along through your environment variables, a lot of times that'll give you some hints as to where some of these files might be stored as well. I put one of them, a screenshot of one of them. This FGL resource path is an important one. And if you'll just check all the different directories specified for your FGL resource path, that's a good start to locating a lot of your files. But you've got your FGL image path environment variables. All of those might be helpful to find files that you may have, let's say, misplaced in your directory structure. So that would be the first big step, figuring out where all of the files are that are needed to run your application. Once you've got that all accounted for and you think you've located all the files you need to get them organized in a way that can be deployed. Now, there's not a whole lot of leeway that you have for deploying a mobile app. you're bound to the structure that's supported on the various physical devices. So all you have to do as far as determining what kind of directory structure you want is a few different properties that we see here. And we'll come back to these properties in just a few minutes, but there's two main properties here for tracking the files in a package. This root directory, project dir bin, is considered the root of your directory structure that will be created when your package is deployed. So as it builds the package, the directory structure that's created on the mobile device will be relative to this root directory path that you see here. Now this is the default root directory. So if you look at your nodes in your packages, your package nodes that you have in your projects view, you'll notice that the root directory for all the packages is project dir bin by default. You can create additional directories underneath the package directory, and you do that by specifying directory node properties that we'll see in just a few minutes. But you really don't need to have a complicated directory structure on your mobile devices. You could just put everything under a single folder, and that would be perfectly fine. But just be aware that you are able to create a more complex directory structure if you feel like you want one. So right here is our root directory. As it builds the project, it's going to build, look here under project dir bin. So for us, that's pool doctors bin, and that's where it's going to look for the files that are used to create the package. And in the directory structure we configure under that in our directory nodes also determines our directory structure when it's deployed. That was a mouthful. Okay, so creating a package, here's our overview. We have all these steps, and we'll take a look at each one of these steps individually in a little more detail. But the first step is just creating a package node in your project, and package nodes have properties that you'll need to set. Most of the properties, the defaults are just fine for them. So notice the asterisk there. We have an asterisk on step 1 and step 2, which is create directory nodes under the package nodes and configure their properties. Well, the reason those asterisks are there is because of those default project nodes that we just looked at a minute ago that you already have in your projects view when you have a VAM mobile project or a mobile project. Both of those types of projects come with defaults, and those defaults for the most part are just fine. Right? You can go in and there's a few properties that you may want to tweak or need to tweak as you try to build your project, but for the most part those are standard directories and are standard nodes with standard properties, and most of them you can leave at the default. Same thing for step 3, confirming the package rules for the platform defined. The package rules remind me of build rules. If you remember, we've looked at the build rules a few times in class to see how our project is built. So the packaging rules to me are a similar type thing, and for the most part, for almost everyone, the defaults for those are fine too. So you might just have a look at them to be familiar with them, but for the most part, the defaults are probably fine. So once you've configured your properties for your package nodes and your directory nodes, you might have a look at the package rules just to make sure you're okay with the default package rules. Then you're ready to build your package. Very simple right-click option. And the same thing for once your package is built, if you want to deploy the package for testing purposes to an emulator or a physical device, that's another right-click option. So steps 4 and 5 are very simple. Just build a package with a right-click option to build, and do the same thing for the deploy with the deploy option. Step 6 on distributing your app to users, of course, is dependent on what kind of app you're trying to deploy. If it's a package for iOS, then you have to distribute your app according to iOS standards and methods. And the same thing goes for Android. So how you distribute your app depends on the platform that you're distributing it to. So here we are looking at these individual steps. And the first few steps, we're talking about the package nodes and then the directory nodes underneath the packages. So let's take a look at those package nodes. We've already talked about the idea that we have default package nodes that are built in for our BAM mobile projects, which is what we're working with this week and last week, or normal mobile projects, right? The non-BAM mobile projects. I don't know that normal was the right word for that, but non-BAM mobile projects, that's better. So here's our package node and our projects view, and you've probably seen this many times this week. There's already 4 built-in packages, 2 for Android and 2 for iOS. And of course, one of each of those is intended for mostly emulators and the other for physical devices. Now, if you're not working with a BAM mobile project or a mobile project and you're basically creating your packages from scratch, that's still not a problem. We have a right-click option here that's Create New Package. So right-click on the Packages node and say New Package. Here are the package node properties. We've seen a few of these properties already because we were talking about this root directory. But let's just take a look at the overall group of packages here that we have for package nodes. There's a description here that you don't really need to worry about because it's already defaulting to a package for Android. Now notice this time we're looking at Android ARM, which is the one we typically use with physical devices for Android. So if you're doing the lab this afternoon, one of the things you'll take into account, I know a few of you are working with physical devices, so when you do the lab this afternoon, take that into account, and if you're working with a physical Android device, you'll want to use the Android ARM package. If you're working with the emulator for your labs, you'll want this Android x86 that matches the configuration that you've been using this week. So keep that in mind. These 2 package nodes are intended for physical devices versus emulators for the most part. Now the exclude from build, if you're for some reason wanting to exclude this package from a build, you can select that option. Here's our platform again. The defaults are fine for that. I think the 2 that you need to pay most attention to up here towards the top are the distribution directory and the root directory. The distribution directory is just where the package, the completed package file, is going to be put when it's created. So this is where it's going to be saved. So once the package is created, and remember the packages are just these flat files that have a special extension depending on whether they're for Android or iOS. So the Android package will end with a .apk, the iOS package will end with a .ipa. Did I say IPA twice? Let me start that over. APK for Android, IPA for iOS. So those output files, that's your finished package, will be put in this project dir/dist-bin. So the default will be, for us, PoolDoctors/dist-bin. So after you finish your lab, you could go out there and look, and you should see your finished package, right? That for our case will end with a .apk. And then here's this root directory that we talked about earlier. The root directory is where the files will be packaged from. That's not very good grammar, but essentially the files will be copied here to this project dir/bin directory by default, and that's where the packaging process will take place. That's where it will find the files. So they get copied there during the packaging process if they're not already there. So notice it's project dir/bin, so we already have a lot of our runnables and whatnot are already saved to our project dir/bin. Those don't have to be recopied during the packaging process, but let's say it's image files. If you remember right now, we're probably keeping all of our image files in an image directory, and those will have to be copied to this project dir/bin directory for the packaging process. So that's where it's going to look when it gets ready to actually build the package. It's going to look in that bin directory. And then according to our directory node properties, that also will determine the directory structure for our deployed device will be relative to this root directory path. Now down here at the bottom, we have all of the information about our package, and you might certainly want to customize some of the things you find here. Here's our package ID. I imagine the name and label for this is fine, but for sure you might want to edit the version information, and anytime you have a new version of your app, you'll want to update that version information, and that's one way to keep track of the current version of your app. So those are things that you'll want to maintain as you release new versions of your project, at least the version property. Now here's the directory nodes. So notice the hint up here at the top says you'll want to create a directory node for each directory from which you need to retrieve files. So by needing to retrieve files, we're talking about moving those files over to that project dir bin directory, right, the root dir that we were looking at a moment ago, so that the package will include those files when the packaging gets done. So that's what these built-in or default directories are for. If you look at those, there's a directory out there that has properties for each one of the paths where we have files in our standard directory structure. So we'll take a look at some of those. If we don't see good screenshots for them, or maybe even if we do, we'll take a look at the real one that we're using for the project. So these are the default directory nodes for a BAM mobile project or a mobile project, and we'll take a look at those in detail in just a minute. Now, if you're creating your directory nodes from scratch, if you're not using a BAM mobile project or a mobile project, you can go in and just right-click on the package node that you've created, and then there's a new directory option in the right-click menu. Now here's the directory node properties. And it looks like maybe we don't have to look right away because the one I picked for the screenshot was the images directory node. And if you notice here, it's going to look for image files, and here's the included files down here, anything that ends with a .png or JPG. It's going to automatically look for those in project dir images, which of course for us is pool doctors /images if you're using our standard directory structure for class this week. So it's smart enough to already go and look in those files. So now you can see when we're saying that it's really important for you to try to remember to save your files as you're working on your project to these built-in default directories out there, because it makes packaging easier. Well, now you can see why that's so, because these directory nodes and directory node properties that are already built in with our BAM mobile project is looking in those default directories for these special types of files. So in this case, we're looking at images, so it knows to look in the images directory. So if you've stored images in some other location for development purposes, then you'll want to create another directory node out there under your package so that you can specify a different source directory so that it can find all the images when it gets ready to do the packaging process. But if you've used the defaults, then pretty much all your work is already done. Let me show you one more thing before I move on. Notice that in addition to the included files, there's an excluded files. So when you actually do your lab this afternoon, you may actually end up using the excluded files property in one of your directory nodes because whenever you have additional applications built into your project, you've got additional runnables being created for those. For example, well, it's not open right now, but our database maintenance node, that group node that we have in our Pool Doctors project, creates a runnable, right? It's the VDL program that we use to update our database and add the job notes table to the database, if you remember that from last week. Well, that creates a runnable when we create that script to update our database. And when you build a package, that package is for a single application. And the database maintenance script that gets created would be a second application. So if you get errors when you're trying to build your Pool Doctors project and it's complaining of multiple runnables, when you look at the error message that you get, the solution for that is to go to your binaries node, and I'll show you that here in a few minutes. That's the node that's looking for the runnables for the project. So you go to the binaries node and you specify any additional runnables that might be hanging around out there in your project, like the one to run the script to update the database, and you can exclude it there in the excluded files property area. And that way it won't include that file in the build process. So more on that here in a few minutes when we finish the slides. I'll go and show you that. So here we're just looking at the package rules. And I mentioned earlier, if you look at these, they're similar to me to the build rules that we looked at a few times in class the last week or two. So those build rules are probably just fine for 99% of the folks out there that are building projects with Genera Mobile. But we always try to make things like that available just for the exception. So if you look at the build rules and you're not pleased with them for some reason, you're allowed to edit the build rules. So at this point, you should be ready to build your package. You've done all the prerequisites by the time we get here. And building the package is very simple. You just pick the node that you're using to build the package, the one for the device that you're creating the package for. And right-click and pick Build. And when you click Build, if you remember the distribution directory that we saw in our package properties was dist-bin, project dir/dist-bin. So this is after the build process is finished. We're out there looking at this distribution bin directory, and there is our package, right? So Pool Doctors _Android ARM APK. And you can see that the name of the package is based on the name of the package node that you have in your project view. So that's where you can find your finished product when you finish packaging your app if you want to go look at it. Anytime you're building your app, though, it's important to kind of keep an eye on the output view. As I mentioned before, occasionally you'll get errors building your package, and those errors will help you figure out what you need to go change. For example, if you do get that message on multiple runnables, we've talked about how to fix that by working with the directory nodes. So if your build is successful, or when it's successful, it will be eventually. You may have to fix a few little things, but once it's successful, you can deploy your mobile app for testing. You can, of course, deploy it to an emulator or a physical device, depending on the package you've created, the configuration and the package node you've created. If you're deploying to a device, you need to plug the device into a USB port to deploy it for testing purposes. In Genera Studio, you want to make sure you have the right configuration selected that is associated with that device. Right-click on the package in the project and select Deploy. So just like building the project, you have a simple deploy option, a right-click option. That should just take a few seconds. I'm sure the larger the project is, the longer it will take, but the Pool Doctors app is pretty small, so it only takes a few seconds. And then you should see the app icon show up on the device with your other apps, and you should just be able to tap it and run it just like you would any other app. Now we've talked about deployment issues a few times. For example, with databases is a big one. If you're going to have a database, a local database on a device, then you'll need to make sure that database is in a read-write directory, an updatable directory. That's not a problem on Android, right? There's no issue with that because it'll automatically be deployed to a writable directory. But with iOS, you actually have to create a read-write directory and make sure that you move your database file and any other updatable files that you need, log files, anything of that nature that need to be written to or updated, need to be moved to this read-write directory that you create when you deploy the app. It's not really when you deploy it, but the first time the app is run. So if you remember, we looked at a routine in the Pool Doctors app that does just that for iOS. And we might just go ahead and review that here in a few minutes just so you can remember. So there's a couple of special classes and methods. One of them is one of the built-in classes. Grab a highlighter here. And you saw both of these in the Pool Doctors app one day. We took a look at these. This base.application.getProgrammed is one of the built-in class methods that we have out there. And that gets your deployment directory on the device. So that's how you figure out what directory the application has been deployed to, so that you could create then a read-writable directory under that directory. And then this is one of the C extension libraries that I think we've talked about a few times this week as well. This OS package is a C extension library, but it also has methods that you can use here to create a read-write directory. So there's a couple of special methods that you'd need to be able to create a read-write directory for iOS updatable files. There's a few examples of that. One of them is the one we've looked at in the Pool Doctors app. Main.4gl is where that routine is. Right after we get ready to start the app, one of the first things it does the first time it runs is go out and checks to see if it's iOS, and if it was iOS device, then it goes ahead and creates a writable directory and copies the database file into it. We also have another example, this Office Store mobile demo project that's included when you install Genera Mobile. There's an orders app.4gl module, and there's a function, orders app install, that you can look for in your structure view, your code structure view. If you look for that, that also has an example of creating a read-write directory for iOS. So there's a few examples. Imagine they're very similar. To distribute an iOS app, you've got two different options. If you're wanting to distribute your app using the App Store, you have to join the Apple iOS Developer Program and submit your app to the App Store. You have to go through that Apple process. If you want to distribute your app as a proprietary in-house app to your employees, you do something different. You join the iOS Developer Enterprise Program, and then you can distribute your app using an over-the-air installation. So those are two different programs, and you can't just join one of them and be able to distribute your app both ways. So if you do have a need to distribute your app both ways, you actually have to join both programs. They're two different things. For Android apps, you can publish your app to any of the app marketplaces out there. Google Play is probably the primary player in the app marketplace arena, so Google Play. But you can also distribute in-house via a website or email. You've got lots of options with Android. So if you will take a look at this URL here, this developer.android.com distribute tools open distribution.html, it gives you a good overview of all the different options you have to distribute Android devices. When you're upgrading an app, there's things that you're responsible for during the upgrade that you need to put some time and planning before you just try to deploy your new version of your app out there. For example, let's say that you have databases, local databases or other types of updatable files on the device for the app. That's something to take into account and determine whether or not it's okay for those files to be just overwritten when you do an upgrade, or whether you need to do some sort of routine to save off that data before you do a fresh deployment. So those are a few things to think about. So you need to make sure that any new files that need to be written to a read-write device are written, right? Go through those routines that we've talked about there to create a read-write directory and copy the file into it. Make sure you isolate and figure out some sort of routine to handle any files that shouldn't be overwritten. Maybe save off the data to a temporary location during a deployment and copy it back in, something like that. Files that need to be updated are merged. You have to be able to handle that. So 2 or 3 things there to think about for upgrades. So here's a few thoughts for an update strategy. So they're suggesting that you always have a special file like version.txt that you can use as a check to see if there's an existing installation of the app already on a device. So you check for the existence of this file. In later versions, you might check for the existence of the file and then check the version that's in the file to see if it's already updated or an older version. So there's a lot of things you can do with this version.txt file they're suggesting. So if it doesn't exist, you're going to perform a fresh install. So you might create the new version.txt file, create any configuration files that you need out there, populate the database in your initial installation, and then again, if it's iOS, copy your updatable files to a read-write directory. And then you do an update, let's say later on, and maybe there's already an existing version of the app out there. This time you're going to detect that there's an existing copy of the app by looking for this version.txt file, maybe checking the version that's inside the version.txt file to see if it's different than the new one, older, and then convert existing configuration files. If you have a new file format, for example, you might want to convert them or replace them if they're replaceable. Upgrade the database schema if you need to while keeping the data. Those are all routines that you might need to work on for a while before your new update. Delete any obsolete files, and again, copy any updatable files to your read-write directory for iOS. And there's a whole topic on this in our Genero Mobile Developer Guide, the Manage App Updates. All right, so that was a fairly quick and easy chapter. So let's just take a look at a few of these things that we've talked about during the chapter. So let's go ahead and pull up our project here. And we'll just start out by looking at some of these package nodes that are built in. Here's the Android ARM that we typically would use for an Android physical device. All of the directories here. Let's just use it for kind of exploring a few of these package directory nodes. Drag this over where you can see it better. So notice here's our binaries. And of course the purpose of this file is to be able to locate all of the runnable files during the packaging process. So here is the source directory where it's going to look for runnables, those .42Rs that you see here. And then if they're not already in this Project dir.bin directory, during the packaging process, it's going to copy them. The destination directory is Project dir.bin. So that's where they need to be in order to create a package from these files. So during the packaging process, it's going to look for them in Project dir.bin and copy them to Project dir.bin. So that's it doesn't actually need to copy them, right, because they're already there. So in a case like that where the source and the destination directory are the same, it doesn't have to do anything. A bit of a time saver. So here in the config directory node. If we look at the properties for it, it's different. The source directory for the FGL profile file, which is one of the files that needs to be included in your package, it's going to automatically look in our project.dir config directory. And if you remember, we had that standard directory structure. One second, and I'll pop this up here to remind us. Can almost fit it. Yeah, there we go. So what it's doing here is looking here in this config directory, and there's the FGL profile. So again, if you've made sure that you've saved all of your special files to these special default directory structures, then everything's already correct with your package directory nodes. All of these source directories are looking in the correct place, in this case to find the FGL profile, and it does have to be copied, right, because it needs to be in project.dir bin, the destination directory. So this is one file, this FGL profile, will be actually physically copied during the packaging process. Let's see a few more. Database, right? So when it's looking for database files, the source directory it's going to look in is project.dir database, and those files too, database files, will be copied to the bin directory. So the file it's looking for in this case is our SQLite pooldoctors.db file. So it says it's going to look in the database directory, and so there's our SQLite database file. So it's going to be able to find that just fine. So you get the general idea, all the different important files. Here's the images. It's going to look for them in those standard directories that were created when we created our new project. So again, if you didn't use a special BAM mobile project or a BAM project, then you're responsible for creating these different directory nodes and specifying source directories for all these special important files and making sure they do get copied to the destination directory for the packaging process. And in our case, it's project.dir bin. So most of my files, they all look like they're accounted for. There was one thing I wanted to show you here that you will probably run into when you do the lab. Well, let me show it to you right here, and it'll save me some work. I created a package this morning for my emulator, and I had an error because I have this create database. This guy right here is an application node, and it has a runnable associated with that application. So that was causing my build process for my package to fail. Same thing here. We've got an add notes application node with this insert rows application in it, and the runnable for that was in bin as well. So when I tried to build my project this morning, it failed because it had multiple runnables. So what I had to do was actually go out and search for them, because I didn't know the names of them at the time. So I just went in, and you can see where I searched for 42Rs. And when we build a project, it's for a single application. It needs to be this pooldoctors.42Rs, the only one that we're trying to build a project for. And just the presence of this add notes and create database 42R file caused a problem. So I made a note of those, and then in my binaries directory node, see where I've got excluded files? I just said add notes.42R, create database.42R, and that was all I needed to do to cause it to skip over those files in the process to build the project. So once I did that, the project built just fine. So that's how you handle anything that should not be in the project that might be laying around out there in your directory structure. And from there, I just went in and built my package. So there's a build and a rebuild. Not much to see if I don't do the rebuild. So there's the rebuild. So it cleans everything up that it did before. And it goes faster than I can go. There, I finally caught it. There we go. So again, you need to kind of monitor that and make sure you don't have any errors. Make sure that it does say that there's a successful build. And then once it's finished building, the only step left to do is to deploy it. Now remember with Android, by just doing another deploy, because I did that this morning, and there it is. That's the deployed app. I don't know if I gave you enough time to see it. See it right down here in the corner, Pool Doctors. So that's what yours should look like this afternoon when you finish the lab.